So for GCSE in trigonometry, there are some values of sine and cos and tan which we need to know. So we need to know sine and cos and tan of 30 degrees. We need to know sine, cos and tan of 60 degrees. And we need to know sine, cos and tan of 45 degrees. And you might think, well, why do I need to know these? The calculator will tell me all of them. These are values that the exam board expects you to know exactly. So a decimal approximation isn't good enough. We need to know the exact values of them. And there are some questions where if you don't know the exact values, but you're using your calculator, you're not really going to be able to get straight to the answer. Also, if they put trigonometry on a non-calculator paper, your calculator won't be there to help you, but almost certainly they'll have one of these angles involved in it, okay? So why are these particular angles? Well, here's the reason why. If I draw, there are two special sort of triangles that I can draw which will tell me the angles of the sine, cos and tan of these angles. The first one looks like this. It's a right angle triangle and it's a right angle isosceles triangle. So this length here is the same as this length here, okay? In other words, if that one there is of length 1, then this one here is of length 1. And I may as well label them length 1. I'll measure in units of however long this is, okay? It doesn't have to be 1 centimetre, it can be 1 unit that long, okay? So one there, and a right angle triangle there. Well, if this is an isosceles triangle, then this angle and this angle are both 45 degrees, okay? So I'll work with this one, that's 45 degrees. This is the opposite, this is the adjacent, and this is the hypotenuse. Now, how long is the hypotenuse? Well, if we use Pythagoras' theorem, we can work it out 1 squared plus 1 squared, and then square root the answer. So square root of 2 is the length of that there, okay? So sine of 45 degrees is opposite divided by hypotenuse. So that is 1 divided by square root of 2. And if you remember your surd simplifying, that is the same as square root of 2 divided by 2. Either of those will do, okay? Cos of 45 degrees is adjacent divided by hypotenuse, so that is 1 over square root of 2 as well, which we can write again as root 2 over 2. Tangent of 45 degrees is opposite over adjacent, so that's 1 divided by 1, so tan of 45 is 1. So that's the first triangle, and that tells us these three. So the next triangle that we need to draw looks like this. It's an equilateral triangle, 60 degrees here, 60 degrees here, and 60 degrees here as well. And I'm not going to mark that on, and you'll see why in a second. Now, I'm going to drop a line down the middle here at 90 degrees to the bottom, all right? And that is going to mean that I've split the top angle in two, so this is a 30-degree angle, okay? So this angle here, not this angle here, this triangle here that I'm outlining in red is the one that we're going to deal with because it's got a 30 degrees and a 60-degree angle in, and those are the ones that we're interested in, and it's a right angle triangle. So what we're going to need to do, though, is know the lengths of these sides, or at least the ratios between these sides. So this one here, this bit here is half of this length at the bottom, and this length at the bottom is the same as this length here. So if that was a length of 2, this would be a length of 1. Okay, so the ratio there is 1 to 2. So I'm going to label that as 1 unit. This length here is 2 units. So what about this one here? Well, let's draw this triangle out just on its own. Oops, that's not very good. Let's have a 60, 30, 90 degree, 1, 2. So by Pythagoras' theorem, square root of, 2 squared minus 1 squared is this length here squared. So 2 squared is 4, 1 squared is 1. So that length squared is 3. So in other words, the missing length is the square root of 3. Okay. Once I know that, well, if we're dealing with a 30-degree angle, this is the opposite and this is the hypotenuse. So sine of 30 degrees is opposite divided by hypotenuse, which is 1/2. Cosine of 30 degrees is adjacent, root 3 over 2. Root 3 over 2, adjacent over hypotenuse. And tangent of 30 degrees is opposite, which is 1 over root 3, which is 1 over root 3. And if you remember your simplifying surds, that is the same as root 3 over 3. So sine of 30 is 1/2, cosine of 30 is root 3 over 2, tan of 30 is root 3 over 3. What about the sine and cos and tan of 60? Well, again, if we've got this triangle drawn, we can work those out fairly quickly. and let's do that now. Cos of 60, sine of 60 and tan of 60, we're going to have to relabel our triangle. Previously we were working with this 30-degree angle and we said that this was the opposite and this was the adjacent. Let's ignore that 30 degrees, let's look at the 60 degrees. This is now the opposite, this is now the adjacent, okay? So sine is root 3 over 2. Cosine of 60 is 1 over 2, adjacent over hypotenuse, or a half. And tangent of 60 is root 3 divided by 1, so root 3. There are two helpful ways of remembering that. Firstly, just draw these triangles out. And secondly, you can remember 1 over root 2, sorry, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. So all of these numbers here are one of these. So square root of 1 over 2 is the same as a half. Square root of 2 over 2 is square root of 2 over 2, so that's these numbers. Square root of 3 over 2 is sine of 60 and cos of 30. Square root of 4 over 2 is 2 over 2, which is 1. Okay, so all of these numbers are either square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, or square root of 4 over 2. Okay, that's just a little numerical quirk that they happen to work like that. There's no particular pattern behind it, but it's just a little helpful aid memoir that all of these numbers that we're trying to remember fall into one of these four categories there. Okay, so that is everything about that particular little exact values of sine, cos and tan for 30, 60 and 45.